So this is Practical High Availability. I'm Christopher Grönlund. I'm the HA architect for HA at SUSE. If you're asking yourself, if you're familiar with the product since before, and you ask yourself, wait, that's the wrong guy. That's true. We used to have another guy called Lars, was the architect. He is now the architect for SUSE Enterprise Storage. And I was a developer of HA, now I took over. This is my first SUSECON as architect, so we'll see how it goes. In this talk, I'm going to try to keep things practical. That's kind of the idea of the whole thing. I want this to be like an entry-level view of using HA, not from a technical perspective as how does it work in detail, more how can I use it, how can I start using it, what does it look like to set up a cluster, how does it work, what are the tools, so on. So that's kind of the approach. Richard is, unfortunately he couldn't come, so it's just going to be me. Originally this is going to be a double act where I did the slides and he would do the demo at the same time. Now it's just me, I'm doing the demo as well, so it's going to be a bit more demo, a little bit less slides. So I'm going to go pretty quickly through that. But in general, I'm going to start by just talking a little bit about the new features in SLE HA Service Pack 2. I'm really just going to skip over that, just show you the slides, show what's in there, because I'm going to actually show you the tools and show you what's in there later on. But I guess, actually I should ask, is there anyone in here who's using SLE HA today? Okay, we have a few. Anyone using Linux high availability from another distribution? Or okay, we have a few of those. Yeah. And anyone who hasn't used high availability at all, this is like the first view of this kind of software. Okay, we have it's about the same vision, so we'll see. This is yeah, this is going to be tricky. Basically, I'm just going to skip over everything and just go straight to the demo. I think that's probably the most interesting part. But to kind of get a base grounding, these are some of the new features in Service Pack 2. If you haven't seen HA before, then none of this makes sense, so I'm just going to skip over that. Instead, I'm going to talk about the real basics. So the way we see a high availability cluster is 2 or more nodes connected in order to make a service available regardless of software or hardware failures. So it's basically not trying to avoid failure, more trying to deal with failure. So failure is a fact, it's going to happen. There's going to be software issues, there's going to be hardware issues, there's going to be physical issues outside of the computer at all, like fires and floods and things like this. And what we have is a software stack designed to detect and cope with problems like this. So the first level of HA cluster and kind of the core cluster that I'm going to talk about and show here today is a local cluster between 2 or more machines. And these can be virtual machines, as I'm going to show you. This can be physical machines in a rack. They usually are in the same data center, so the interconnect, the network connection should be fairly good. But you can also stretch this to the metro level, as we call it. So where you have 2 data centers within a distance of roughly 20 miles with a decent connection between them. So less than 15 milliseconds of latency, pretty much guaranteed. If you can fulfill those demands, then you can set up a metro cluster where you have one node in one location and another node in another location, and you mirror between them. If you need to go beyond that, if just having a cluster stretched over a single city is not enough, we also have the geo cluster where you can basically set up separate clusters in separate locations and have them manage the same service. So you have a service running in one location, and for some reason, maybe there's a flooding, maybe there's power outages, maybe there's a big issue like that, you can fail over the service, so it's now provided by a data center in another location. And this can be on another continent even. So those are kind of the stages of high availability. The other kind of thing that I want to emphasize is that even though we're selling SLE HA as a product, really it's more of a process. It's not something that you just buy and you install and you go, yeah, now I have high availability. It's something that you have to maintain, you have to keep an eye on it, you have to be aware of how it works and also what the limitations are. For example, you can configure a high availability cluster for a database when the database is basically empty. You're setting up, you don't have many customers. But as your business grows, the needs for that database also grow with it. So you have to monitor disk usage, you have to monitor latencies for failing over, starting, stopping. There's timeout issues, things like this. So it's never really a completed, finished thing. And that might seem depressing, but it's also just reality. Is that if you want the services to stay available, you're going to have to work on it nonstop. So yeah, that's the goal. What we want to do is provide continuous operation as far as possible. And the other key thing that we want to provide with SLE HA is data integrity. So just making sure that the service is available is not good enough. You also have to be sure that your data is protected in the case of failures. So that's the other kind of side of the coin. So we're on one hand providing service availability and service monitoring. On the other hand, we're providing file system and mirroring tools on the storage level to ensure data integrity and integrating these so that the cluster is aware of how your file system and block devices and databases work so that it can handle failure in a way that doesn't compromise data. And yeah, the other thing to think about when you're setting up high availability is where are your single points of failure? It's very easy to configure some parts of the high availability setup so that you can fail over very easily and handle the failures. But you have, for example, if you only have one network interconnect between your nodes, then that network interconnect becomes a single point of failure for the whole cluster. Because if you lose communication between the nodes can no longer know if the other one is alive or dead. And unless you have some other means for these nodes to interact, the only safe way, the only way to ensure data integrity is to bring the whole cluster down. So if your goal is availability, that's not a good thing. So you have to think about these things as well. You want to have at least redundant, abundant network interfaces. We have various methods for fencing, so power control or SPD, which is storage-based fencing, ways for a cluster to ensure that the information that it has about the whole cluster is all the information it needs to manage the resources. And yeah, the way we approach continuous operation is by reducing the mean time between failures and also the mean time to recover. So these are two factors to think about. And these are the factors that are going to influence the way your cluster works and how long you can count on an outage being from the time of the failure to cluster detection of the failure to recovery from the failure. I'm actually going to skip over the use cases because I think they're not really that interesting unless you actually see something in practice. So what I'm going to do is actually show you how we set up a cluster from scratch. So I'm going to go to this screen. I've been cheating. As an engineer, I know everything can go wrong, so I've been making the room for error as small as possible. So what I have is I have a little tool which manages virtual machines, and I can show you the status of my virtual machines right now. So what I have are two virtual machines running SLE HA Service Pack 2. They each have an IP address assigned, and they have already configured shared storage between them. So this is like a basic setup that I already have, and I also configured. Yeah, actually, I can go back to this here. So these are some of the things that I'm skipping over. So you need time between the service nodes to be synchronized. How you do this is not something that we prescribe, so that's why it's not part of the bootstrapping scripts, because if your cluster is not connected to the internet at large, you can't use a generic NTP server, so you have to have your own. So we just say that the times should be synchronized between the nodes, but we don't really say how. Same thing goes for a watchdog device. We require a watchdog device. In this case, because of the virtual machines, I'm just using the softdog watchdog device. That's in production, that's not really recommended. They're usually a better watchdog device that you can set up, but this is just also an example. And then also, all the nodes need to be able to reach the other nodes using just the host name. So that's also like basic network configuration that I'm already prepared in this demo. So first of all, I'm going to start off by just running a few commands. So I have some basic setup just to make it easy to run commands on specific nodes or run them on all of the nodes. Of course, when you're doing this yourself, every administrator has their own favorite tool. You may be using Chef for Puppet or just bash scripts that you wrote. That's fine. I don't really want to get into that. But in this case, I just wrote some simple scripts just to make it clear what I'm doing on each machine. So in this case, I'm first going to run the cluster init command on node HA1. And as part of that, we also configure OCFS2 for a shared device. So this is a cluster file system that allows writes and reads from both nodes at the same time. So it's a file system that's available from both of the nodes simultaneously. And I'm going to use that for a database later on. So, oh, actually, not for the database, but for another service. For the database, I'm using DRBD. This is also configuring SPD, so the storage-based fencing already. I haven't talked about fencing, but fencing is a really important concept in HA clusters and something that a lot of basic tutorials and basic walkthroughs skip over, which is unfortunate, but because you really need fencing for a cluster to work properly. As soon as you have a database or any kind of shared data or any kind of shared state, which needs to stay in a good shape. So this all is going to be configured basically. Then once the first cluster node is up and running, we run join on the second node, and it's going to go to the first node, find the cluster, find the state of the cluster, and then configure itself appropriately. So at that point, we're going to have a complete running cluster with 2 nodes, and we're already able to look at that. So hopefully, if this works, I'm just going to try running this. So you can see there are some messages coming up that's kind of confusing. So I don't have any firewall configured on these virtual machines because that just simplifies things. But if you do have a firewall, it will actually go in and open the necessary ports that it needs to communicate. It does some synchronization. So we have a tool called SUSECON, which is kind of a, what would you call it, like a lightweight Dropbox, where it's using that to synchronize configuration files between all the cluster nodes. So this is something that we also configure by default, just to make things easier when you're setting up. Yeah, now it's already scrolling off screen. There is an error reported, which may look bad. That's just because the device is not formatted before, so it doesn't have a disk label. And at this point, yeah, so at this point, it's already configured a cluster. It's started a cluster. It's starting the Hawk, which is the HA a web service for looking at the cluster, and it's created a user, it's set the password, and everything is up and running. So actually, we could already go to this address and take a look at that. What you're going to do, the next thing you're going to see is this then. Because what we do is we always run over HTTPS, but we don't have a valid certificate yet. So we just have a self-signed certificate. So at this point, we're just going to have to ignore that. And now we can log in. And you can see we already have a few resources in the cluster. So at this point, we actually have a full cluster. Even though it's just one node, it's actually a valid cluster. It's not a supported cluster because you don't have any high availability at this point, except that if something crashes, it's going to restart. But it doesn't really have anywhere to go if there's a problem with the node. Actually, it's saying it has 2 nodes. Oh yeah, because I ran both of it. Yeah, okay. I ran both steps, so yeah, you have a full cluster. So I'm not going to show you more of this right now. More than this is the web management interface that we have that's available. It provides you can configure resources from this. We have wizards, so you can run more complicated things. So we have, for example, you can set up an NFS server just from a wizard. So you just provide some basic information, and you hit go, and it configures all the resources that you need for that. You also have monitoring information, like what's the status of the cluster. So really handy, it just gives you a check mark that says everything is okay. If everything is not okay, it's going to tell you. You can see the error that happened. If you then want to see more about what's been going on, you can go into the History Explorer, which can then show you, for a given time period, what were the events that happened in the cluster during that time. So this can be quite useful. We also have, so what I can do is I can go to one of the cluster nodes, and we have a command line interface called CRM. So what I can do now is I can run CRM status, and we get basically the same information. So yeah, that's kind of difficult to see. Let's see if I can improve that. I don't know if that's any better, but let's go for that. So this shows you the basic status of the cluster, kind of the same output as in the web interface. You can also, so if you want to monitor ongoing, there's the crmmon command, which basically runs the same thing. And if you don't give it the -1, it's going to keep monitoring the cluster. So any changes that happen, you see it here immediately. So everything that I might show in the web interface is also available from the command line. And that includes basically all of the functionality, including the wizard. So yeah, now I'm going to do one step here, which is setting up the certificate, so we don't have to go through that process again. And at this point, I should be able to go to the host name I have. Yeah, yes, no, I can't, because that's a virtual ID. All right, so next step. What I want to do now is configure DRBD. So DRBD is basically a block device that's mirrored over the network. So you don't have to have a SAN or a shared storage device available. What you can do is, as long as you have storage available on each node, you can configure DRBD, which then mirrors over the network your data to the other node and keep this synchronized. And in Service Pack 2, we actually ship with DRBD 9, which on paper supports up to 32 devices connected. But in actuality, it's not quite ready. So we're still only supporting 2 devices. You can mirror between 2 nodes, but we do support active-active. So you can have a device and provide a block device that's actually running a cluster file system like OCFS2 or GFS2, and you can write from both nodes at the same time, and this is going to be synchronized correctly between the nodes, all on the networking level. So still just plain old hard drives on both sides, but appearing as a mirror device for the cluster. So this is just doing some basic configuration. So we're setting up a resource file for the DRBD device, which is just pointing for each node, pointing at the correct actual device that it's mounting, and then the network address that it communicates over, and then also what the name of the device that it's going to provide is going to be. So, and then we're synchronizing this to all of the nodes, creating the metadata for DRBD on this device, telling each device, so on all the nodes, we tell it to go up, which is, now it's up active, so it starts communicating. And then we tell it that, oh, actually, one of these is now the primary. So unless we say that, DRBD is very conservative. It doesn't want to cause any data problems. So in case you already had precious data on this device, it's not going to actually overwrite any of that. So that gives you a lot of control in bringing in data. So like as a basic setup, maybe you already have a big data set. You can actually bring that into DRBD and configure it as a DRBD device, and then bring it up, and all your data is already there. But in this case, we're saying, okay, so one of them is primary. That's going to force the other one to get overwritten. And then we create a file system and a mount point. So I'm just going to run this script. And if I'm going too fast, just tell me, and I'll go into more detail if you want me to. So here we can see it's creating the metadata block, and I forced it to active, created the file system. All that seems to be okay. So that was 10. And let's see what's this one. All right, so now I'm going to set up a database that's using this DRBD device. And there's a little bit of hustle and bustle. Yeah?
Will that file system get mounted with the boot up, or does it have to get mounted with the cluster startup?
So it doesn't get mounted at boot up because, I'm going to create a cluster resource that manages that file system. So it's going to mount it as a cluster resource so that I can have dependencies on that. So I can say, okay, so this database that I want to have the data stored on this DRBD device, actually it needs the file system to be mounted on the same node before it actually tries to use it. So that's the way it's configured now. If you're not using the cluster software at all, you can have it mounted startup. You have to make sure that DRBD is available on the machine. So it's not quite as simple, but in general, and that's one of the points that I have towards the end, is just things to think about, is it's really easier if everything that's involved in your cluster is managed by the cluster software. Because then you can keep track of startup, stopping order, you can have dependencies there if you need them, and so on. Otherwise, you're never quite sure if, when does the system decide to start this service? Does it even start before pacemaking starts? Things like that. So it just makes life easier. Yes?
Didn't we see any involvement of LVM when we initially created the file system?
Right, yeah. So I don't use LVM in this demo. So you can actually use LVM on the base level, so to manage all your devices, and then create a DRBD device on top of an LVM volume. But then you can also use LVM on top of DRBD, so to then divide up the DRBD device that you created into multiple volume groups. So LVM kind of fits in at multiple levels of the cluster. But yeah, in this demo, I just decided to skip that because it just kind of complicates things even more. But yeah, definitely. in a real production system, you probably want to use LVM at the bottom so that your device that you're setting up DRBD on is an LVM device so that you can grow it when you need to or modify it if you have to. Yeah. So this is just doing some basic database nonsense. If you know MySQL, then you know what's going on. If you don't, you don't really have to care at this point. It's just setting up the basic MySQL database. If you do know MySQL, you're probably going to say, hey, no, why don't you do the secure setup so it removes the test table and all this stuff? But in this case, I actually want to keep it because we use something like the test table to do monitoring of the database. So the cluster resource for the database is actually going to go in as a database user, look at the data, a particular table in the database, and make sure that everything is okay before it reports okay as the status. So I'm going to keep all of that default stuff. And this is all now configuring the database on the DRBD device that I set up before. So it's mounting the DRBD device on one of the nodes, going in, setting up the database, and then unmounting it again. And this is before creating the actual cluster resources. So that part is now the next step. So this is using the CRM shell command that I showed you before to create the resources that we need for managing the file system, the DRBD device, and the MySQL database, all as cluster resources with the dependencies between them. So the first thing that we have here is a wizard that's available in Hawk, but it's from the command line you run them as a CRM script. So this is going to create a set of resources to manage a DRBD device as a multi-state resource. So it's actually running on multiple nodes, and on one of the nodes, it's running as a promoted node, promoted resource. There's a little bit of trickiness involved in that. You have to have a lot of configuration for timeouts and so on. That's all taken care of by this script. So they just simplify things a little bit. Then I'm just going to configure some regular cluster resources. So we create a file system resource to manage. So the file system resource manages mount points. So this is just saying, OK, mount the device called DRBD named DB in this mount point, and the file system type is ext3. So pretty basic. We then create an IP resource. So this is a virtual IP. This is so we can reach the database from other nodes. We're just going to point towards that IP address, and then the other services are going to look at the database at that point. And then we create a resource for the database. And we group all of these together. And the group means that all of these resources should run on the same node, and this is the order that they should start and stop in. So it's going to start, it's going to mount a file system, then it's going to set up the IP address, and then it's going to start a database. And then if it has to stop them, it's going to go in the reverse order. So this kind of simplifies having to set up the constraints. Then we also want to set up co-location with the master resource for DRBD. So we're saying that the whole group for the database needs to run on the same node as the master DRBD. And we want DRBD to be promoted on that node before we start the database. So this is, we separated the two concepts. It's a little bit unintuitive at first. Natively or instinctively, we want to think of like, OK, so this resource depends on this other resource. Then that means that they start on a particular node together, they start in a particular order. But it's actually useful to be able to say, oh, this service depends on this other service, but they can start as totally separate machines. Or this service needs to start before this other service, but or they have to start on the same machine, but they can start in any order. It doesn't really matter, so you can start them at the same time or one before the other and so on. So these two concepts are separated. It does make the configuration a little bit more complex. That's why we have the group concept as well, which kind of bundles these. and saying, okay, so these three, they all depend on each other, they have to start on the same machine, and they have to start in this particular order. So if I then run this, now unfortunately I only have one screen, otherwise you could see them appear. See if I'm fast enough to go, if I go back to here. Actually, I want to go there. Okay, so let's start doing that. So now you're going to see the resources start appearing. And what it's actually doing is it's creating the resources and then starts mounting and starting the database. So at this point, everything is up and running already. But you can see, so the web interface is actually real time. So if we do any changes, they appear in the web interface immediately. So that's quite a nice feature. So let's see where I am at. I'm doing pretty good. So now I'm going to show another thing that's. So we actually have support for running Docker containers as cluster resources. So this is actually showing a bunch of things all at once. You can actually run systemd services as cluster resources. So you don't need a specially written resource agent. For a lot of the services that we have today, you can actually run them as, if you just have a systemd service file for it, you can run it as a cluster resource directly. You say, oh, I need systemd :docker running. What I'm doing is I'm creating a clone. Oh, I didn't see that. It's kind of cutting off a bit. It's creating a clone. This just means that it's going to run this on all the nodes. And the reason for creating this as a resource, exactly as I said before, is that now I can set up dependencies on that. So when I then create my container as a resource, I can have it depend on Docker actually being running, because that's now also a cluster resource. There's a few, so maybe you see this interleave equals true. So for a clone, that means if I create a dependency on that clone, I don't have to wait for all of the clones to start running. So if I create a dependency and say, like, oh, my resource wants to start after this cloned resource, without interleave set to true, it's going to wait for the clone to start on all of the nodes before it starts the dependent. But with interleave true, then it's just going to wait for the local copy of the resource to start, and then it can move on that node. So that's pretty handy. Then I'm going to pull down the container. Hopefully I have networking set up, otherwise it's going to get stuck here. We'll see how it goes. And I create a database for, so my container is gogs. I don't know if you know what that is, but it's basically a clone of GitHub. And I'm going to set up a database for that. And then I'm going to create the resource for that in the cluster and set up the necessary dependencies. So we're going to see if that works. This is probably going to take the longest because it actually has to go out and get the container. So we're going to see if that works. So in this case, I guess I can show you the dashboard. So we also have this dashboard view, and it's showing basically the same thing as the status view. It's just showing in a more compact format. So it's more like a blinking lights view. This is just showing the resources as they're being created. The nice thing with this is that you can actually monitor more than one cluster from the same interface. So on this screen here, it's a little bit cramped. But if we had more space, I could actually fit more than one cluster status in the same view. So you can actually have a whole range of clusters that you may be monitoring. You can monitor them all from the same interface. Actually, I think it's already done. Could that be true? It could be true. All right. let's see, do I have any steps left? Oh yeah, so let's just do that as well. No, that one doesn't seem to do it. It doesn't. Yeah, because I think I already have it. So yeah, so this is already set up. So actually, what I can do now is I can go to this, and go to right, and I'm just going to set up this real fast. So this is the configuration for GOGS, which is the service that we're running now. So hopefully I get this right. And this should now configure the database and set up, get the service running. Right. So then we can create a user. I'm going to create it for myself. I can create it for my SUSE.com. And if you're wondering, the password is Linux everywhere. Extremely secure. You obviously want to do something else if you're doing it for real. No, that's that one. So there we go. Now I actually have GitHub up and running on my test cluster. And it's running in a container. It's using a database, not running in a container, because you don't want to do that. Yeah, that's it. So that's a very quick run through setting up an actual cluster that you can use. So what I can show now is, for example, you can see that we have the database running on HA1, and I have the container service running on HA2. So we can go in and go to, okay, I'm going to have to do it here. Go to HA1, and we put that node in standby. So standby means move all the resources running on this node to the other node, or to another node. So basically, this node is not to be used. We want to go in and manipulate it, move everything away from it, and then when it's done, we can go out of standby mode, and we can move resources back if necessary. So we're just going to put this one in standby. And we can see on the dashboard that we now have everything moving to the second node. So you can see it actually restarted this service because the way I configured it, it's dependent on the database. So if we're moving the database, we have to first stop the service that uses it, move the database, and then restart. That's probably not necessary, but that's the way I configured it this time. If I actually had anything in here, you can see that it's still there. I can actually try creating, let's see if I can remember how to do that. To create a SUSECON demo. So this is just like GitHub, if you've used that before. It's you create a Git repository, you can access it. Yeah, so now we have our Git repository up and running. And the data for the actual repository is stored on the shared cluster file system that we set up, the OCFS2 device. But the database is stored on the DRBD. So, but it's all available. So now if we go out of standby mode, we'll see if it actually moves the database back or if it keeps it. Yeah, so it just kept the database on HA2 and just restarted the services that are cloned to run everywhere on the other node. So that's that. The other thing I want to show you is the History Explorer. So what we can do now that we configure everything is that we can generate a cluster report for the last hour. We're just going to collect all the logs that are created on both nodes and all the information about the system and save that in a tarball. So this is if you used the cluster solution from SUSE before or from the other vendor that I probably shouldn't mention. There's a tool called CRM report or HP report. So this is actually doing that in the background. And you can get that tarball if you want to send it to support or if you want to show it to someone else by just downloading from the interface. So it's a really convenient way to create these kind of reports instead of having to remember all the command line options for the reporting tool. You can actually just choose, okay, so this is the time frame and just create it and you can actually look at it directly in this interface. And here you can see all the things that happen. So we started, so the timestamps are totally off because me and my computer are both in Swedish time. So this is the time that I think it is right now. You can see we can look at individual events. So the way Pacemaker works, which is the core technology of the HA cluster, is that it manages the cluster through transitions. So it will look at the state of the cluster as it is right now, and then look at the constraints and configuration that we have, and calculate what it should be, what the state should be. And if those two are different, it's going to create a transition graph, which is showing how do I get from where I am now to where I ought to be in the fewest amount of steps. And this is actually completely how it works. So you might think that the way it works is reactive to events. So something happens and then it acts on that happening. But that's not actually how the cluster software works. Instead, every time something happens, it just calculates, it looks at what is the actual state of all the resources now. And it calculates what is the state that it should be in. And figures out all the things that it needs to do to get to that point. So that's a subtle difference, but it actually makes a difference. So here we can see the first transition that we're doing is just getting the cluster online. So this one is actually not very interesting. But you can see the initial configuration of the cluster. So this is before we actually set up any resources. So we just have some basic settings. These are actually created by the cluster itself. So it's not something that you can configure except for the cluster name, which is useful if you have a geo cluster. And then we only have one node. But then we can go to the next transition, and we can see this configuration change. So in the next transition, we already have all of these resources set up. And that's because these are all set up by the cluster init script. So the bootstrapping actually sets up all of this for us from the beginning. And we can also look at the, so we could look at this. So this is showing the transition graph that the cluster calculates when it figures out that the current state of the cluster is not the same as what it should be. So then it actually calculates a graph like this, which is, these are all of the steps that we need to take, either in parallel or in sequence, to get to where we want to be. So this can be really useful for figuring out why is it doing what it's doing, because sometimes it's just things are happening, you don't know why. Then you can go in and see, okay, so this is all the things that it needs to do. And then you can also see that maybe it was trying to, so it called monitor, and it's expecting that to succeed. And then it's going to call start and expect that to succeed. And then you can see that during the implementation of this, maybe the start failed. And that's going to change. Then it's going to recalculate a new state transition because no longer is able to follow this plan. So that's kind of the way that works. I probably should show you how to configure a resource from this. So you can actually create new resources from the web interface as well. It's a little bit difficult on this tiny screen. Let's see. But you can actually, so what you can do here, which is kind of nice, is that you can actually get a list of all the available resource types. So either you can use systemd directly. That's going to give us a really long list. So, but we also have these resource agents, which are specially written scripts that are cluster aware. So they're doing a little bit more work to make sure that you can monitor your services in a meaningful way. So, for example, the database resource, as I said, it actually goes in and looks at specific tables that you can configure. So tell it to, okay, look at this table, make sure that it's there. Yes?
Are there any defined SAP classes?
Yes, there are. Yeah. So we have, I can actually show you, we have in the list here, we have SAP database, which is managing a database for SAP. I actually don't know the details of SAP because we have a whole team dedicated to SAP at SUSE, and they are handling they're also handling the HA configurations for that. So, but yeah, we have a SAP database for handling the database for SAP, and also SAP instance for handling the actual SAP resource. Yes?
Do you have to license SLE for SAP to get the SAP resource agents, or are they included in just the HA extension?
So the actual resources are included. Yeah, so you don't need to license SLE for SAP. What you get with SLE for SAP is all of the configuration around these resources and a lot of other things that you basically need to have to run SAP on SLE in a meaningful way. So while you can, just licensing HA, you can run SAP on it. It's probably going to be a bit of a struggle, I would say. So it's a lot easier if you have the SLE for SAP product. And if you license SLE for SAP, you get HA included in that license. So those are bundled together. But yes, yeah, these are all included in the base.
But the agents are available without the requirement to license SLE for SAP because it's quite expensive for some clients.
Yeah, so
as long as you know what you're doing, you can use the base HAE product, bring up the SAP and include it into HA.
So I probably shouldn't say yes to that because I actually don't know for sure that there might be some caveat in the licensing. What I know is that we include the agents, but I don't know exactly what the licensing terms are, so I can't say yes if that's true. But in theory, if we disregard support status, yeah, you can configure SAP just using the resource that we have here. And yeah.
This is true.
Oh, yes. Go ahead.
And this is true for SAP HANA resource agents?
That one, I think, is actually not included. So there's a special resource agent for SAP HANA in the SLE for SAP product, and that one is not included in the base HA package. No. Yeah. And yeah, we have a lot of resource agents for things that are not included in SLE at all. So for example, we have special agents for managing virtual IPs on Amazon cloud. And to do that, you actually need the Amazon client API. So, and that you need to get from Amazon because it's not open source. We can't include it in SLE. So you're going to have to get that separately, but you already have the resource agents for using it once you actually have it installed. So, so there's a few caveats to some of these, but yeah, that's what's available. Oh, okay, I don't know what I did. Ah, yes, I know what I did. Because I selected the Amazon agent, it was trying to look up all the information about it, but I don't actually have the Amazon API installed, so it failed to get the information. That was that. Yeah, any other questions on this so far? Yes?
You were saying that you don't recommend SoftDog for production workloads.
what would you run?
So there's usually a hardware watchdog device available. So if you're running on a hardware device, that always has a hardware watchdog. You just need to figure out which kernel module to load and to load the appropriate one. If you're running in a virtualized system, most of them have a watchdog device that they provide. So a virtualized watchdog device, and you can use that. The problem with SoftDog is that it's running on kind of a in-kernel level. So if you have other issues in the kernel, the watchdog is not going to work. Whereas a hardware watchdog is running a little bit lower, so it's a little bit more secure. That's the basic functionality. Yes?
I have a setup with one customer. He's using for a long time a cluster of Squid server, active and passive mode. When it's active, when something happens, it fails to the other node. He wants to. It's kind of a waste of resource because a database. I cannot have a database together like MySQL. Oracle is another. We can have Oracle RAC, but in normal terms, I could have Squid running in both servers, and have the clients load balancing in some way. What's the better way to go to this solution, to this approach?
So there is no general answer to what is the better way. If you're running a cluster for high availability, there's going to be some waste because you need to have redundant resources. Otherwise, if you're using the maximum capacity of both your nodes at all time, if you have a failure, one of them is not going to be able to handle double the load at this point. It won't be able to take over. So you need to have redundant resources so that you can handle a failure of some of them. That's kind of the whole idea of having a cluster. So you're going to have that waste.
The load is not the biggest problem. One server can handle all the requests, but they need two because of failures. One hardware may failure, so the load should go to the other one. I thought in making Squid in clone mode. However, if I stop one resource, it stops Squid in both nodes.
Right.
Is there a way to handle this?
So yeah, so you can set up active-active. So you have it cloned running on both nodes. If you then go in and stop Squid, it's going to stop both of them.
Yeah.
The way you want to handle that is to instead go to standby on the node where you want to stop everything, or just create a constraint that tells Squid that you can't run on this node. So that I can actually demonstrate how that looks. So we can actually say, okay, we have the database running on HA2. What I can do is I can create a migration that just says, okay, you're no longer allowed to run on that node. And this is something that you can create for for cloned resources as well. So you could say that to Squid is that, oh, Squid, you're no longer allowed to run on this particular node. And that's just going to shut down that clone instead of shutting down all of them. Because yeah, if you go in and stop all of them, that's going to stop the whole thing.
So I could create two Squid reserves, one for one node, one for the other node.
Yeah.
Okay.
Yeah. Yes.
So if you have active of two clusters and one cluster fails, the other cluster is going to pick up without interruption in the application.
So yeah, so when I was talking about active-active here, it was just talking about a single cluster. So we have two nodes run in the same cluster, but we can have services running active-active on both of them. But we can also configure, so as part of SLE HA, we provide two different kinds of load balancers. So we have IP-level load balancer, which can actually make sure that your requests are uninterruptedly moved to the other node. And we also have HA proxy, which on a HTTP level, if that's useful to you, can handle the same kind of thing, like session state management and so on. But I'm not going to go into the details of that. But yeah, you can configure it so that that's out of time. You can configure it so that it handles the resources on both nodes, and when there's a failure of one of them, all the sessions are seamlessly transferred to the other one. That's possible. But it's very application dependent, so it's difficult to give a generic answer.
How would you achieve 5 nines?
Yeah, so that's again something that we would have to look at your specific use case, like what is it that you're trying to do, and then look at exactly how you can optimize timing and so on. Because yeah, 5 nines is not a lot of downtime, so that's going to take not just cluster software changes, but maybe even looking at the hardware and networking and so on to make sure that everything is working in the right way. But yeah, it is possible, and we do achieve 5 nines in particular setups. But it's not, you're not going to get 5 nines just out of the box, just putting up a cluster without very carefully setting things up. I guess that's the answer I can give. Yeah. Yes?
Yeah, so in your lab, you have a 2-node cluster, but best practices, you want at least a minimum of 3 nodes in your cluster, right?
Yeah, so this is actually an interesting point. The most common HA cluster that we have is a 2-node cluster. Even though for quorum, in most solutions you want to have quorum. So you want to have, if there's a network partition, you want to have one partition being bigger than the other one. So you want to have an uneven number of nodes. That is definitely a recommendation. So we would recommend 3 or 5 or 7 as well. But it's actually a very common configuration to just have 2, because with fencing properly configured, a 2-node cluster is able to isolate the other one. So let's say you have a 2-node cluster and there's a network failure. We no longer have communication between them. If they are sharing a single storage device, like a SAN, on a separate network, we can use that to tell one of the nodes to shut down. And once we confirm that that node is down via the shared device, we can then move on with just a single node. So you get safe data takeover even in a 2-node cluster. So actually, this is actually a common configuration.
So yes. In the 2-node configuration, would you recommend to have like 2 SBD partitions instead of 1 to avoid that signal down here?
So, I mean, the simple answer is yes. 2 is better than 1 in this case, just extra safety, but it's not necessary, and there are common setups in production that only have a single SPD between them.
Because I've seen customers having problems with their Stone device in a VMware environment,
right,
where it just goes south, and all of a sudden you have a cluster with no functional Stone device. So
yeah.
Sometimes it's better to have, in addition to the VMware Stone device, the SBD partition as well, just to pick up the slack in case.
Yeah. So this is all dependent on how much availability you need. So yeah, we support having we call a fencing topology, where you have multiple fencing devices configured in sequence. So you can actually try one fencing device, and then if fencing fails through that mechanism, maybe SPD doesn't, the drive is down, you can actually go on to power-based fencing or something like that. But that's all dependent on how important yeah, exactly. If you want 5 nines, you're gonna need stuff like this, but yeah.
Thank you.
Yeah. Yeah, so unfortunately I think I'm pretty much out of time, but any more questions, I'm gonna be around probably at the kiosk for HA, so you can come and ask me there. And yeah, that's it.